This is the next video in our series where we use Google Gemini, that's Google's AI, and Google Colab Notebook to analyze some data, learn about statistics, explore our data. And that's exactly where we're starting now. We're going to do some exploratory data analysis, and for me that means summary statistics, data visualization. I'm always going to start with that because you start to understand your data. You find some surprises. You might find something that's wrong, and you can just fix that along the way. So in this video, we're going to take one of our columns, which is a numerical variable. There's a couple of them, so you can practice on the rest. We can take one numerical variable, and we're going to do some summary statistics, that's descriptive statistics, and data visualization. So here we are back in our notebook. Everything is still running. You can see there my CSV file is still available. So I'm just continuing this recording. If you were to shut this down, come back, do remember that you'd have to import your file again. It's not going to be there for you. So let's carry on, and we're going to start with a new text cell, and I'm going to do 2 hashtag symbols, and I'm going to call this exploratory data analysis. Shift enter, shift return. You can see I have my little drop down. Now that I have that, let's go back up and let's just close this as well. And now everything is nice and neat. So what I want to start with is just univariate analysis. So I'm going to create a new text cell, and this is what I'm going to type. 3 hashtags. So this is now going to be a subsection to this exploratory data analysis. And you can see the font size is even smaller, but it's still larger than normal text, so it still serves nicely as sort of as a section head. And what I want to start with is my first column, which was my age column. So another text cell, and I'm going to do 4 hashtags now. It's getting kind of ridiculous, but remember, you can go up till 6 hashtags. And I can see it's even smaller. It creates these little drop downs, these little ways to collapse at least your code. And so I can continuously do that. But that's going to collapse based on the number of hashtags that you have. So you can keep things very nice and neat. Now what I'm going to do in this section, not for this video, but I will run through each and every one of my columns. This univariate analysis, I want to get an idea of my data. I want the story that the data is trying to tell me, I want that to start coming out. I want to tell people what I'm going to do here. So I'm just going to add a new text cell, and this is what I'm going to type. We start with summary statistics of and now you see something very weird. It's got age in there and it says column. Now this is a language or sort of markup language called LaTeX, L-A-T-E-X. I think the creators called it LaTeX. Many people pronounce it LaTeX. It is mathematical typesetting, proper mathematical typesetting. If you've seen a mathematics heavy journal article before, that's usually done in LaTeX. It's just a nice, easy language, and it's so powerful. It can do so many things, which means it can get complicated. But the way that we're going to use it is very simple. And then the way that I tell this notebook that this is LaTeX is by starting and ending with a single dollar symbol. That's called inline mode. So it's going to create this mathematical typesetting just right inside of this normal English sentence. You also get block versions or display version. That's $2 symbols on either side, and that's going to just center it nice in the middle in its own block, as you would see in a mathematics textbook. And it's not necessary to do this here. I just thought I'd take the opportunity just to show you another way of formatting. Remember, we've already seen those little backticks. Now this is another way to go about it. The part that you see there, this is this backslash, T-E-X-T-T-T. That is a keyword inside of the LaTeX, let's call it language. And that knows what to do. Instead of parentheses, this language uses curly braces or just braces. And I'm going to put age in front of there. So it knows what to do with this age. It's going to do a true type font. That's what the text TT stands for. Let's execute and just see what it looks like. And you can see this age, once again, it's slightly different font, slightly different size. And it's just a formatting thing. It is for mathematical typesetting. So if you want to write an equation there, you want to create a matrix or a vector, you can do that all with this language, and later on we'll see just how to do that, see the common things that we can do with LaTeX. But I thought I'd use this opportunity just to show you another way to format things. And now I want to have a summary statistics or descriptive statistics of the age column. And for the first time now, I'm not going to type the code. I'm going to get the AI to do that for me. So I'm in this code cell, and I'm going to hit this generate button. Once I do that, you see it jumps. The focus jumps to my chatbot here. As I said, I'm going to leave it at Gemini 5. We can also see empty cell. So this is telling the AI that I want to generate code inside of this empty cell. So I'm going to be sort of specific about what I want here. I'm going to say calculate summary statistics of the age column. Now, this is a large language model. Sort of there's many things that you can do. So I'm going to put age just inside of double quotation symbols. It's one way to go about it. You can use other sort of typesetting if you want. So the age column in the df data frame object. And I'm putting df inside of those fancy little tick marks. Now, this kind of thing, using specifically JSON, for instance, JavaScript object notation inside of your prompts, are very, very useful. And, these are things that might work, might not work. I want you to experiment with them. So this is what I've done, and now I'm just going to hit the little send button, and you'll see it starts working. And what I have found, though, unfortunately, that depending on when you use it, it can be very, very slow. I do most of my development inside of Visual Studio Code, and my data analysis inside of Visual Studio Code, and there I use the GitHub Copilot for my pair programming, and that executes my prompts very, very quickly. I'm used to that kind of speed. This is kind of slow, but it gets the job done. And now you can see a couple of things. You can see my cell has now been populated. It's got this little red bar with negative. It's got nothing in it. So it's saying I'm not changing anything in the cell. I'm just adding with a little plus in the green bit. And there's the code that it's written. df, open square brackets, in quotation marks, age. And that is the way just to create one column. I'm just going to select one column. The way to do that is say df, that was the name we gave our object. And inside of square brackets, I'm going to put the name inside of quotation marks of that column. Again, you can use single, double quotation marks, it doesn't matter. And that creates what is called a series object instead of a data frame object. The series object just means I'm just doing a single column. And then on that column, I'm going to call the describe method. That's a function that applies to this object that now already exists, the series object. And the describe method, if I hover over that, you can say it generate. You can see the little tip that comes up. The little information says it generates descriptive statistics. That's exactly what I want. And so I'm going to go here to the right hand side. I'm going to say accept and run. I like what it's done. I wanted to accept that code and I want to run it. So let's do that. And there you go. The code was now executed, and look at this nice information we have. For the age column, we have the count. There were 918 cases. The mean age was 53.51 years. The standard deviation was 9.43 years. The minimum was 28 years. First quartile was 47 years. The 50th percentile or second quartile or median all mean the same thing as 54. The third quartile was 60, and the maximum was 77. So I have nice summary statistics. Now look at the right hand side as well. It's just going to give us a little message to our prompt. It says 918, number of non-null entries. The average age was 53.51. The standard deviation was 9.43. That's the spread of ages around the mean. So it gives you this nice little bit of information. Look at that, 50th percentile, meaning 1/2 of the individuals are younger than 54. So it's just the median, the 50th percentile, or the second quartile. There we see the third quartile, and the maximum, the oldest age. So a nice bit of information. Now, one thing that's not done here, for instance, is the interquartile range. The 75th percentile, or third quartile, minus the 25th percentile, or first quartile. So just 60 minus 47, very easy to do. That's just going to be 13. But I just want code just to confirm sort of that calculation. So let's try and do that, see what it comes up with. I'm going to say code, and again, I'm going to generate with AI, and I'm going to say, and I'm going to type it. So I've said calculate the interquartile range of the age column. Again, I did that out of this empty cell, so it's going to do, pull focus on that cell. Let's execute that. And now it's done quite a laborious thing, a very laborious thing. It's actually created, again, a series object, df, square brackets, quotation marks, age, dot quantile 0.25, and it's assigned that to a computer variable called q1. Remember, the equal symbol in most computer languages are not the equal symbol for that you see in mathematics. It's an assignment operator. It looks towards its right and sees what is there and then assigns it to what is to its left. So it's going to do this calculation on the right and assign it to this name that you give it to the front. Now that is a lot of code that's really not there. It's even using a print function with an F flag. So it's going to say this interquartile range IQR for age is, and then plug in this value IQR into that. That's way too laborious. So I'm going to write some code by hand. Now this is obviously going to work, no issues there, but I'm going to hit cancel because I wanted to get used to what I like to do. So I'm going to hit cancel. I don't like that. I'm going to do this by hand. Now you could just accept that. That was absolutely great, but I wanted to get used to what I like to do. So I'm going to do the following. I've written this code by hand. I've left a little message to myself. Calculate let's put there, the inner quartile range. And look at this. I'm saying take that stats module inside of SciPy. Remember we said from SciPy import stats dot. There's an IQR function in there. And what argument do I want to give this IQR function? Well, that whole column, that series object, df, square bracket, quotation mark, age. If I had did that back, I get the value 13. And that's exactly what we thought it would be. 60 minus 47, that's going to be 13. It does a few extra things. It tells me it's a numpy.float64 object. That just means a number with a decimal place. But it gives me the solution that I want, 13. Now, Gemini is going to see sort of the way that I like to code. And so if I were to state this again, maybe next time it picks up on my little hint here that I just want to use shorthand, the shortest, neatest type of code that you can get. But that code that it wrote, absolutely correct. I could also have put in my prompt, calculate the interquartile range, but use the IQR function from the stats module. But then you had to know a little bit of Python, And so it's this double-edged sword. You can accept that what it does, learn from the code that it writes. Eventually you learn a bit more code. Sometimes it becomes easier just to do it yourself rather than get the AI to do it for you. But I think it's a lovely journey, and I'm sort of very happy that this journey exists versus the old way of just learning, the hard way of how to code. I think this is a very nice introduction of how to code. Now that's only one part that we know. We have some idea of this age variable now. Nice and neat, very nice. Look at how nice the values are. And then once again, you can put a little text cell there and say something about these values that you found. You can give some information. You can just add some interpretation if you'd like to. The next thing I want to do now, though, is now that I have the descriptive statistics, I want data visualization as well. That's part of how I learn what this information is in this data. And I'm going to do that for every significant column in my spreadsheet, significant to the research question or questions that I'm trying to get to in this project. So I'm going to create a little text cell. This is what I'm going to type. We add a histogram to demonstrate the distribution of age values. So histogram, typical, not to put in histograms in the journals, in my field. We'll use box and whisker plots. Later I'll show you a box and whisker plot. But for us just to understand this distribution, I think a histogram is great. And so I want to create this histogram. Let's do that. So let's do that by not typing a bunch of code, because I told you the matplotlib package is quite a beast and it can do so much, but it does mean it's quite complex to use. So I'm going to just hit the generate button and let's type that out. I'm going to say the following. So I've typed the following: create a histogram of the age column. Add the title distribution of age values. I put that in quotation marks. It's a large language model. You've got to experiment with those kind of things. Add the horizontal axis label age in years. I put my units inside of square brackets. And I'm going to add the vertical axis label frequency and start the histogram bins at 20. Remember bins, these little rectangles. I want to start at 20. The reason why is I looked at my minimum. I said it was 28. So I thought, 20 is a nice place to start. And I want a bin width of 5. So how many people were between 20 and 25? How many people from 25 to 30? That's something I want to describe specifically for age. We all know what age is. We can see it goes from 28 to 77. So I think a bin width of 5 is appropriate. Let's see what Gemini comes up with. And there we go. That was actually quite quick. It's quicker than it usually takes. So I'm happy with that at least. Now I can see the little red minus sign there. The red, there's nothing that it wants to change. Because remember, you can, click in a cell with code in it, and then you can just type a new prompt to say, change the code for me. Then you're going to see the changes that are going to be made in red, and the green is what's going to be added. So it's created a computer variable called bin underscore width. Now that's called snake case. We don't want to put illegal characters in our computer variable names. And so a space would be an illegal character. And the typical thing then is just to, either just do juxtaposition and capitalize the first next letter, so the W would be uppercase, or to snake case, and snake case just concatenates the words with underscores. And it set that to 5. Then it's done sort of an elaborate thing. It's created this computer variable called bins, and it's assigned to that NumPy object, and it's using the range function to start at 20, then go to the maximum, and it's added the bin width and the step size as well as then the bin width of 5. So quite elaborate code, not something that I would do. I think that's way too elaborate, because you could just say bins equals, and you can see that's happened right in there. So it's calling plt.hist. PLT, remember, that's the shortcut, the namespace abbreviation for the pyplot package of matplotlib. The hist function, so plt.hist, that's hist function, open close parentheses, because it is a function, and now we're going to see a bunch of arguments, and arguments are separated by commas. The first argument that it gave is actually just that series object, so df age. So we know that's just going to be the age column, comma. The second is called a keyword argument. It's an argument that actually has a name. So there's a bins argument, and we're going to set that equal to this object that we created, bins, comma, then the keyword argument edge color is going to be set to black. So we know our rectangle is going to have a little black color. plt.title, and it's given the title there. plt.xlabel, plt.ylabel, and then plt.show. The show function actually produces the plot here in the notebook. And so once again, when you've done this a couple of times, you start picking up, the way that Python works. I'm going to accept and run, and let's see what happens. There we go, and I think that's quite a nice looking histogram. Isn't that cool? I can see my bin widths, so between the ages of 25 and 30. Now you'll have to go to the documentation to see if it's left closed or left open. In other words, if I look at the number, if someone's exactly 30 years of age, does it fall into the left or to the right bin? You've got to just make sure of that. You can see it's kind of sort of trying to be a normal distribution, and you can learn from that. It's not quite a normal distribution. We'll have to run a statistical test on that just to make sure when we do get to the statistical test, but we sort of have a nice idea now. We've got summary statistics and data visualization just of that column, and if I didn't have to just narrate over all of this, it won't take you that long. The sort of thing that you have to wait for is just for Gemini to generate this code. I think here, for me at least, inside of these notebooks, it's a tad slow, shall we say. But look at this. This is fantastic. You are learning about your data. It didn't take us much. It didn't take much to do any of these. Everything can be done right here using Gemini, or once you know a little bit of Python, like this, like quick and easy one there, you can just pop those in between as you learn how to use the language. So I think you can do the rest of the numerical variables all on your own. Those that say int64 for their data type, you can do those. Just be mindful, some of them, like the heart disease column that was encoded with zeros and ones, it's going to say that that's int64, but it's not a numerical variable. It's actually just encoding for a binary categorical variable. So be careful of that. In the next video, I'm going to do one of our categorical variables.